Hello and welcome to another LeetCode video. Today we're going to be continuing on with the JavaScript challenge and we're going to be doing problem number 2700, differences between two objects. So this is once again going to be a JSON method that's going to compare two objects, kind of similarly to what we did in our last couple. So in this one, we are getting two deeply nested objects and we need to represent an object representing their differences. In order for there to be a difference, the key has to exist in both objects, and then we just represent the difference in the values in an array. So let's actually go through this, and let's just go through each one of these, and this is going to help us build some intuition. So for object 1, we have an empty object, and for object 2, we have 1 and 2. We have A and B. So as you can see for here, we're returning an empty object because in order for there to be a difference, both the objects have to have the same key, but the values have to be different. So A and B is only in object 2, and there's nothing in object 1, so anything with an empty object is going to have nothing. Okay, let's go to the second example. So here we have two objects again. So for A, their values are different. So we are going to represent the difference there. So we're going to have an object, and then we're going to say, okay, for A, their values are different. So what are the different values? So one has value 1, one has value 2. So we're going to represent those differences, 1 and 2. For V, their values are also different. So for V, we're going to have 3 and 4. For X, their values are the same. And for Z, so for Z, you have to keep going down recursively into the keys. So for Z, you have to say, okay, is this a value or is this an object? It's an object. Let's go recursively again. Then in this object, they both have an A. Okay, so we're going to actually write it like this. So we're going to write Z A, and then finally we're going to compare the values. 1 is null, 1 is 2. So we're going to have null 2, and this is recursive. So you see how this key structure is preserved. So that's going to be important. Okay, and so it's like this as the output. All right, and now let's actually get into the next example. So for the next example, we have this two objects again. So we're going to have an object, and we're going to compare. So for A, they're the same. For V, they're different. So we're going to say V. And what are the different values? We have a 6 and a 7. Okay. And now for Z, these are actually arrays. So they are different, but let's take a look how. So for Z, these arrays should be like an inner index. So this is index 0, 1, 2, and these should be keys. So at 0, they're the same. At 1, they're different. And at 2, sorry, at 1, they're the same. At 2, they're different, right? At 4 and a 3. So we're actually going to represent 0, 2, and now we're going to have the two differences. So 4, 3, and then they are also different at key 3, a 2 and a 1. But notice if one array is longer than the other, so this is key 0, 1, 2, and here there's only key 0. So the zeros are different, but we're not including these because they're not in the other one. They have to be in both. So it's actually Z2, and then we have Z3. So it's actually Z3, 0, because this Z3 is the array, and then it's an index 0. So it's Z3, and then this is another object with 0, and then the difference here is 2, 1. Definitely kind of confusing, but we'll get into it. Okay, so I think I have to give you one more close. But yeah, that's going to be that one. So let's keep going. So that is another piece of intuition is if there's two arrays and one's longer, we only need to include the differences in, you know, they're both there. But the nice thing is for arrays, the indices of arrays are keys in JavaScript. So it's going to be pretty straightforward there. Like we can just use for in for arrays and objects, and it's going to work the same way. So that's kind of nice for us. Okay, so let's go for this second example. So the A's are the same, the V's are different. Actually, I think we just did this one. Yeah, example 3 we just did. Okay, so let's actually move on to example 4. So for example 4, we have two A's, but their values are different. So for one, we have an object. So if we're going to have an A, for one, we have an object. And for the second one, we just have an array. Right? So whenever we have an object and an array, those are going to be different as well. And so we're going to return this object here. Okay. Now for 5, what do we have? So we have an A and a B, and they're exactly the same. They're just flipped. So they're saying apart from the order in the keys, the two objects are identical. So an empty object is returned. Okay, so let's go through our things that we can possibly have. Okay. So 1. What's one thing we can have to compare? So we can have primitive types here. right? Primitive types. Let's actually make this text bigger. Okay, so primitive types. So if we have primitive types, how do we deal with that? Well, it's pretty easy. We can have a 3 equals, and that's going to take care of a lot of our things. So we can have like O1, or let's just call it, object1, maybe object1. We can just say if these are strictly equals, then these could be primitives, or maybe they're the 2 objects in the same memory, or regardless. If they're strictly equals, let's just return nothing. Okay? So we can do that. Now we have null types. So for null, how do we handle null? Well, let's think about it. So if they're both null, the strictly equals will take care of it, right? They'll just both be strictly equal. Otherwise, we can just say if one of them is null. So if one is null, let's return a difference because one's null, one's not, right? So then we can just return object1, object2 here. Pretty straightforward. Okay. So that's the null case. What other cases do we have? Well, another case is, what if one's a primitive and one's an object, right? So that's going to be another case. So primitive plus object. Well, as shown in one of our early examples, they aren't the same, right? So that's going to be like here. This wasn't a primitive, but either way, like if this was B1 and this were just a 5, they would be different. So if we have a primitive and an object, let's just return those as well. So let's just say they're different. So object1, object2. What other cases do we have? Well, we have an array and not an array, right? So array and an object, or whatever you want, plus not array. Those are also different, so let's return those. So object1, object2. And then finally, we have like our recursive case. And a recursive case is what? It's going to be 2 arrays or 2 objects. And so in this recursive case, what do we actually need to do? Right? So we need to actually go key by key in the first object. If it's in the second object, what do we need to do? Then we need to do our value comparison, right? Then we can recurse down and do our value comparison. So if in the second object, recurse down to compare further. If not, let's move on, right? So we're going to do that. We're going to, so if, whoops, mistake there. Okay, so let's actually do this. Let's do this. Okay, so if the keys are in both, then we need to recurse down, right? For example, like here, if the keys are in both, we need to actually recurse down into the actual object and start comparing them, because it could be like a key with a key with a key, right? It could be like Z with A, with B, and so on. These could be like a bunch of inner nested objects. So if the key's in both, let's recurse down. Now, once we actually get some output, what we want for the keys is we actually want to return an object. And then once we do this recurse down, we return an object. We want to check, is the object empty? Because if the object is empty, that means we recurse down when we found no differences. So we need to find, is the object empty? How do we find if the object is empty or not? Well, we can just take the keys property of the object and we can just say if that's greater than 0, right? So we can just say like object.keys length is greater than 0. That means we do have, a difference of greater than 0. If that's the case, then for the key that was the same in both of them, let's add this object. So for this key, let's add whatever this output was, right? So for every single key, you want to have a difference. And so that's kind of what it's doing here. For every single key, you want to have a difference, whatever this returned. This might be an object, it might be who knows what, right? Typically, I think it's going to be an array, but, it's not, like, it might be different things. Okay, so that's what we need to do. So, yeah, that's what we need to do. We need to figure out, like, how many differences are there, and then we need to be returning that. And so, as you can see, like, yeah, so for like this key, there needs to be this object and so on. Okay, well, let's actually start coding it up now, right? Like, I think we have enough. We have all of our base cases and we have all of our things that we need, right? So let's go over it one more time. We have primitive types, If they're the same, there's no difference. If null, if one of them is null, then we just need to return, both of them because one of them is null. And then if primitive and an object, then we need to return this as well. So let's figure out also one more thing. Like, let's say we have two primitive types, and how is our example going to handle if those two primitive types aren't equal? Like, let's say we recurse down into some objects, like for this case here, and let's say we have these v values. We recurse down, we have a 3 and a 4. How is that going to handle something like one of these? So actually, we're going to handle it here. So if any one of these is not an object, then we're going to return this. Because that means if one of these isn't an object, that means either we're comparing a primitive and an object, or we're comparing two primitives, and if they were equal, they'd be equal here. So this is going to handle the case where our primitives aren't equal. So that's going to handle everything. So let's go over it one last time. So we have the primitives, we have the null, we have the primitives that are not equal, or a primitive and an object. We have an array and not an array, and then finally we have two arrays and two objects. And so now we have enough to start coding. So let's do that. So what's our first case? Pretty straightforward, right? If object 1 does not equal object 2, or sorry, it does equal object 2, that means it's two primitives that are equal. So if that's the case, then let's just return here. Okay. Now we have the other case where we need to be checking these nulls. So if object 1 equals null, or object 2 equals null. If they were both null, then this would have returned true. So that means one of these is null and one is not. So that means we can return this right here, right? So we can return 01, 02. Okay. All right. And then what we need to do next is we need to check the types for the third part. So if type of object 1, so this is object 1, this is object 1, object 2, object 1. So if type of object 1 is not an object, right? Or type of object 2 is not an object. So if one of these is not an object, then we obviously need to return here. So we're going to return here as well. So we're going to say return 01, 02. This is object 1, object 2. This is object 1, object 2. Okay, all right, this should be an if. Okay, so now we have the array case where if one is not an array. So if array dot is array object 1. So if one is an array and one is not, right? So if one is and no one is not, and the way we're going to do that is we're going to do this. So if this means that one is an array and one is not. If both of them aren't arrays, it's okay. If both of them are arrays, it's okay as well. So we can do this array object 2. Then we're going to return here as well 1, 2. Okay. And now finally we have the recursive case. So we're going to have a constant difference. Then we're going to say for const key in object 1. I keep doing it like this, but this is actually object 1, object 2. Okay, so for the key in object 1, we need to check if object 2 has the key. If it does, we need to recurse. If not, we can just move on because they both have to have the key. So if we say object 2 dot has actually we could do some other things, right? So we can just say like object 2 key. That means it has it as well, so that works as well. So we can now we actually want to have the recursive case, so we can say like const recurse maybe equals object diff of object 1 key object 2 key. Essentially, if they both do have this key, we need to recurse one level deeper and we need to figure out what to get there. And so now we're going to get this value. So this recurse, so actually this difference is going to be this. This difference is going to be an object. And so what we need to do here is we need to keep populating this object, but we only need to populate this object if this recursive thing is at least like 1 long, right? So we need to populate this object if this recursive field is at least 1 long. So it's either going to return an array or it's going to return. Yeah, I think it can return a bunch of things, but essentially we need to check how long is it. Actually, I think it's going to return an object. Yeah, I think it should return an object because remember, an array is an object, so these are objects as well. Okay, and so we need to. So yeah, arrays are objects, objects are objects, so no matter what, we're going to have an object. And so what we need to do is we need to actually check, is this recursive thing, is this returned? This is going to be the difference of, we're stepping into the key. So for example, like let's say here, these z's are different. So it's going to say, it's not going to know if they're different, but it's going to have 2 z's. So it'll step into this object for one of them, and then it'll step into this object for the other one, and it will return a difference. So it will actually do it. It will actually recurse twice. But essentially, this recurse is going to be an empty object if there are no differences. So we need to check if there are differences. And so we can do it like this. So we can say object.keys of recurse.length. So if this is longer than 0, then it means there are differences. It's longer than 0. Then we could say diff at key equals res, right? We are saying, okay, these 2 keys are the same. And so if there is a difference, then we're going to add that difference at the key, and we're going to keep populating this object to give us all of the differences. And so finally, let's see here, diff key equals res, and now finally we need to return this diff, right, at the very end. Okay, so hopefully that works. Let's take a look. Temp of object 1, let's see. Type of is not defined, so that's that. Object.keys. So this should be recurse, not res. Okay. Let's see here. So we do have a wrong answer, so let's double check. So what do we have? ACCM, and then we have ACCB. And we are saying the difference is ACF. So what should it say? It should say ACF, but then there should also be a C. Yeah, there should be a C also here. And it didn't catch that one, so it didn't catch this 1 true, 1 false. Yeah, so let's double check our code here. So this looks pretty good. This looks pretty good. This looks pretty good, I think. And then if array is array, yeah, that looks fine to me. For const key, if object to key, const recurse. I wonder if I missed some like diff key equals recurse, return diff. Yeah, it should be fine, I think. Ooh. Yeah, that's fine. That's fine. So for constant object key in object 1, let's try to change this because this could be problematic. So let's just say object2 dot has property. I'm not sure if this will solve it, but I think this is like the safer way of doing it. But let's just double check. Yeah. So actually, I was gonna say the problem with doing things that aren't this, like this is like the safest way for checking for keys. If you do key in object2, you might have some issues. I think there's like some prototype issues with this kind of way, or also object2 key is also not like, this is going to be the best practice. This way right here is going to be the safest way to make sure you don't have errors, as you can see in this example. So we did it like I would recommend checking for keys if you want to be as accurate as you can this way. Okay, but that is going to work, and so hopefully that makes sense to you how we went through all these steps, and then we're recursing, and then we're checking to make sure there is actually a difference before appending, because we don't just want to append an empty object or an empty array or whatever it would be. Okay, so that's actually going to be it for this one, and if you liked it, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.